You are listening to Tech Nuggets and Thoughts Podcast, the show that focuses on principles and practices of coding and some interesting trivia around technology. We discuss all those things that a developer needs to know to craft better software. Listen to Nikhil, Christian, Siddesh, Mandar talk about their experiences and learning, which will make you a better developer.
Welcome to the 6th episode of Tech Nuggets and Thoughts. We shall continue our discussion on testing from the previous episode.
The points that we've been discussing about reaching out to other systems, this adds to the previous point of first principle of writing tests. This adds to repeatability. Mm-hmm. So unless the test is repeatable, unless it fails every time or unless it passes every time, we cannot trust the test.
Yeah. So basically, try avoiding flaky test.
Yeah.
Yes. Make sure that your tests are not flaky. Now, flaky means tests that sometimes pass and then sometimes fail. You should not be in a situation with your team that you look at Jenkins, you see the tests are red, and the first thing you think is, let's just rerun them.
Yeah. There are some reasons which might, make this flakiness creep in, like things that are related to time, like
oh yes,
so time-based things, then network-related things, which we can probably try to avoid consciously. But then there is something that also makes a test flaky, and that is multithreading.
All these things are important. So regarding time, to just give you some funny examples that I encountered during my career, tests that only would run in the UK, but not anywhere else, because of time zone. Tests that would run any day of the year except some day in September or October and some day in March.
That's for daylight saving.
Exactly. Yeah.
I didn't know about UK.
The assumption that a day always has 24 hours does not hold true. When daylight savings are active, there are days that have 23 hours and days that have 25 hours in your time zone.
Mm-hmm. Calendar is a very funny thing, not just time, because there are countries when they adjusted their clocks, and actually the difference between a day is actually 5 minutes or 5 seconds for them. So when this is built into, for example, in Java's calendar library, it knows about this. So when we calculate this, you'll see this interesting things happen.
The Java calendar
look it up.
Is the Gregorian calendar. But there's more sophisticated calendars available implementing the same API. Did you know that in, I think it was 1582, 10 days were removed from the calendar?
10 days?
Yes, 10 days. And this was done by Pope Gregory. Before that it was the Julian calendar. After that it was the Gregorian calendar, named after Pope Gregory. And he wanted to fix two problems. One problem was a problem with farming. In Europe, you have seasons, and these seasons are relatively precise. And when your calendar is off by 10 days, then this is a problem for farming. And the other problem he wanted to fix is these religious dates, they were actually based on a lunar calendar, and somehow the calendar was off. So he had to fix this. The problem was caused by the Julian calendar being not precise enough regarding leap years. And the imprecision of the Julian calendar from about 50 BC, when Julius Caesar had created that calendar, and Pope Gregory in 1582, it was about 10 days off. So those 10 days were removed from the calendar. 4th of October was followed by 15th of October, if I remember correctly. The USA did not do that. Well, at that time they didn't exist, but whatever pilgrims went to America and then founded the USA, they didn't do this until about 200 years later. So they actually had to remove 11 days from the calendar because there was one leap day too much that they actually followed.
Now do this when 24 into 60 into 60 equal to 1 day, and then we'll face all such problems.
Exactly, yeah. Don't do that. Google has a very interesting blog article where they explain how they deal with leap seconds. The Leap seconds are typically inserted or removed from the 31st of December, and because it is a problem for some systems, the time team in Google uses something they call SMARE, where they slice this second into lots of microseconds and spread it out in a flattened Gaussian curve around the days before and after 12th of December to minimize the potential risk for systems that can't properly deal with such things.
Oh, the Gaussian curve actually has a use.
It has lots of use, actually. Yeah.
Never came across. Good to know.
Wow.
So that's about time, and so if you have to develop systems with time, you probably cannot test enough.
Actually, same goes for multithreading as well. The scenarios that can occur when a lot of threads are operating on a shared object are numerous, and it's not always easy to replicate them. The easiest way to deal with it probably is to not share objects.
Yes, functional programming. Do functional programming.
Not have state.
How about using fixtures? Can that make the like having annotations like at before and after?
Well, they serve test isolation,
Mm-hmm.
but they do not help us finding multithreading problems. They make multithreading problems, and they actually rug them under the carpet.
Okay, but actually that means that tests should run in any order.
Yes,
It should be possible.
Tests should be. I like test randomization in the sense of the sequence of tests is going to be randomized by the framework. Do that with JUnit, do that with the scenarios in Cucumber, see if they still run the same way.
Yeah. That's again part of they should be isolated, meaning that they should not depend on each other.
Yeah, they should run parallelly in multiple threads.
Yes, if they're isolated, then test parallelization is the next thing. Although,
Would that make it fast?
Yes,
Even
definitely.
Yeah, so already unit tests are supposed to be fast, and if you run them parallelly, so I mean, why I'm asking this, that should you target them in that way, that I need to run them.
But if you support test parallelization, you bring the test isolation thing on a next level. When we talk about test isolation, we typically mean that the result of one test should not influence any other test. Which means if you run tests in any sequence, you should always get the same results. Also, if you omit tests, any number of them, those tests that are still run should produce the same results, no matter which and how many other tests you have omitted. As soon as you run tests in parallel, you need isolation basically not only in space, but also in time. For example, you might have a test that creates a user, does something with the user, and then removes the user for isolation. The next test again creates that same user, does something and removes it for isolation. What if you run these two tests in parallel? That's what I mean. You now need to also isolate in space-time and not only in one of them, in both.
So spin up two in-memory databases to operate on it.
Maybe spin up in-memory databases as many as you have threads. Yeah, manage them via thread local. That's one possible solution. Another, that's a technical solution. You can have a solution based on the data that you say that each test has to create unique data and operate on unique data. That's another approach. And I'm sure that there are approaches out there which I haven't encountered
Which
yet.
means no copy-paste. Unique data means no copy-pasting tests.
No copy-paste anywhere. I thought we covered that already.
So Nikhil, you were talking about principle. Is there any other principle that you would like to share regarding testing?
There's one very interesting thing. It's called wet.
Okay.
So when we talk about code, we talk about dry. Right? Don't repeat yourself. So we have to make sure when we are writing production code that we do not repeat the same block of code anywhere and reuse it as much as possible by extracting it, making methods around it, or whatever applies. In tests, it probably at times helps to not do that, because that allows us to have separate maybe data, maybe databases, spinning it up or shutting it down, or even the amount of effort that we would spend in isolating or extracting common things reduces when we focus on not enforcing dry on unit tests. That does not mean that we write bad tests. It just means that we do not actively enforce dry. And sometimes it is termed as wet, just as an opposite of dry.
And it makes perfect sense if you think of how test-driven development evolves production code and how it evolves test code. There's something that Robert C. Martin says about this, which is the following. As the tests get more specific, the code gets more generic. And the specific part reflects the wet part, the generic part reflects the dry part. We introduce abstractions like methods, classes, and all those principles in order to dry the code. Don't repeat yourself. Remove redundancy. In tests, we want redundancy. We don't want redundancy on repeatable flows, but we certainly want redundancy between test cases on data.
So, basically now, how does one ensure that he really has a good test coverage? Because code coverage is a very tricky thing. Executing something is different and verifying something is different. Christian has a very good analogy actually. I remember regarding a bulb. Could you share that?
Yeah, it's like when you want to test something, the execution is like switching your light switch, and the verification is looking at the bulb.
Exactly.
And by just having operated the switch, you don't know whether the bulb is actually working or not, or whether the grid has power or not. Yeah? And a test that doesn't verify is like just operating the switch without looking at the bulb.
So code coverage can be very tricky.
Exactly.
Idea to guess. So how do you ensure that you have?
Yeah, because measuring code coverage is like checking if you've operated all the switches. If you did not operate the switch, you definitely have not verified the bulb. But if you operated the switch, you only know you could have verified the bulb. You don't know whether you actually looked at the bulb.
Okay, in this case, even TDD is very helpful then, because you are actually asserting every behavior, right?
Yes, because first I look at the bulb and see it's not on. That's my failing test that I first have to write according to the laws. Then I implement the switch and operate it, and now the bulb is on. And then I know, okay, it's working. The verification is there. But that decays. That's something that we have to keep in mind. As long as a project runs, the more of that actually decays and rots inevitably just because of passing time and people changing stuff. So how do we ensure this coverage, not just of execution, but the coverage of verification? And there's a new concept coming up for that, which is mutation testing, where you have a library that will take your tests, take your production code, run the test, see, okay, everything is green. And then it takes the production code and starts changing it.
By itself?
And sees, yes, by itself, and sees, do the tests still pass?
Oh shit. Yeah, that's bad.
I don't call it bad, I call it badass. That's the badass form of verifying stuff. Yeah? It's still relatively new.
I see potential of this kind of thing for hack intrusions.
That's an interesting thing. I've never thought of mutation testing from the perspective of security. I've thought of it from the perspective of safety already, but that's a very interesting perspective. Because for me, that's a new perspective. I don't have a spontaneous answer to it, but I will take it as a homework from this podcast that I'm going to think about this.
Is there a tool that does this right now?
There are tools. I would have to Google it.
Meanwhile, What you pointed out actually is, I find at times is a missing feature in testing frameworks. So testing frameworks or even coverage frameworks tell us that a particular code or line or a statement or a path through the code was executed, but they don't tell us if there was any assert in the test at all. I mean, if there was a way to find out if every test block has at least one assert statement, that would be really, really helpful and probably identifying it. I don't think it is hard, because the assertion library usually is part of the testing framework, like in JUnit. Maybe in Mocha there are plugins that follow a particular interface for assertions, but I don't know, we don't have a way of today identifying if there's an assertion inside the test.
Now that Christian is already looking for tools, let's switch to that topic.
I just want to cover one more bit about it. So, coverage is easy to fake. That's true. Coverage is very easy to fake, but coverage is still a measure that we can rely on as a criteria, at least. I mean, with the faith that whoever developers are writing the test will write assertions, with this faith, it's a criteria that we can potentially use to see that we have covered enough paths or flows through the code.
Yeah. So I use coverage. I love coverage. So how to deal with that risk? That risk is a culture thing that has to be addressed. Yeah. But, a high coverage, like 100%, does not guarantee that there are assertions. A low coverage guarantees that there are no assertions. Yeah. So it means that a low value of the coverage metric has a high meaning. The high value does not necessarily have a high meaning, it can have a low meaning, but that's what we then find out with mutation testing. And I just googled it, Jumble is one of those frameworks.
Nice.
Yeah.
Okay. Interesting. So how high is high enough?
Is it Pareto, something we can derive from there?
Pareto is something I like to apply to legacy code. Because in legacy code, it is very difficult to achieve 100% coverage.
What is Pareto?
Pareto is the 80-20 rule. And you can apply it on a lot of things. For example, in project management, we say that 80% of the effort are spent on only 20% of the project, and 20% of the effort are spent on 80% of the project. And Pareto for this would mean that, maybe 80% or something like that are sufficient, because for 80% of the coverage, I need to spend only 20% of the effort, and for the remaining 20% of the coverage, I have to spend 80% of the effort. And for legacy code, I think that's true. It's true because legacy code that's not written test-driven is not decoupled, and therefore not testable. So it's difficult to write tests for some of the code. For newly written code, I wouldn't settle for anything less than 100% in the application partition. The main partition can have less. For example, if you have a Spring application, if your main is tested or not, your main is just going to be one line. I don't mind about that. Yeah? That's going to be indirectly covered by so many other things. But the application itself, for new code, I wouldn't settle for anything less than 100%.
There's just a thought that I would like to share. When I'm working with teams, I usually I usually set 80% as a gating criteria for any code that has to go to production. But since it's easy to fake, I believe in asking another question. I term it as peer confidence, because ultimately coverage is meant to be confidence. So the question is this, that would your peer or someone, let's say someone's code is going to production, this is a question for the peer of this developer, like would you be confident to support this code in production without the developer? So it's a test, since it's a matter of confidence which cannot directly be assigned a number. The question or the answer does not have a number, but peer confidence is a metric that not a measurable metric, of course, but a sense metric that we can probably use. Ask other developers, other peers, how confident are they in supporting a developer's code in production in the absence of that developer. That's a measure that tells us how the team believes in their code written by a developer over and above the tests and coverage that the developer delivers.
That's a lovely thing, because it will automatically take into account the criticality of the product. If you know if your product is down for 10 minutes per day, nothing is going to happen. Your confidence will be different from if you know this is a pacemaker. And it's okay, yeah? I think it's okay that in certain applications we apply less scrutiny and in other applications we apply more scrutiny, because there is just a difference in criticality. And that difference in criticality has to be reflected in the project. If we treat everything with the same criticality, we either risk that critical projects will have less scrutiny than they need, and then problems will arise from that, or we apply scrutiny on projects where the scrutiny is more expensive than the project justifies. So there's always a sweet spot of scrutiny for business, which depends on things like criticality. And the peer confidence metric implicitly takes it into account. It's a lovely thing. I said I would not settle for anything less than 100%. But I would be very careful writing 100% or any other number as a written metric for developers to forcefully apply.
Right.
The reason why is I've experienced the following thing. A company, a very renowned company, was hired by another company to develop tests for them, as an example. A framework and example tests. And they wrote down in the contract 87.5% coverage for a specific module. So what was the result of that? A test that called the create file function without any assertion.
Yeah.
And I experienced something else, not caused by coverage, and therefore just executing, operating the switch without asserting, looking at the bulb. I experienced a similar thing with mocking. I once looked at had code where I said, what is this mock doing? And this mock looked so senseless, I just changed the return statement of the function to return null, and all tests still passed. If you mock too much, you have a problem. And so one of the reasons why I don't like mocking is already what we discussed about structure and unit and what are the boundaries, and you go too much fine-grained and then you have to modify too much code when test code when you refactor. But there's more to it. Every time you mock, a kitten dies. Actually, obviously not a kitten dies, but every time you mock, you lose coverage.
Yeah. Just to add to that, actually, I think of mocking as programmable stubs. So essentially, we are specifying what the stub should do when something happens in the test. It's almost as if writing the production code, because that's what the code was supposed to do. So
Yes.
we're replicating the logic in the test, the logic that is already there in the code.
Exactly. And so mocks are a duplication. People think that they actually isolate using mocks, but the opposite is the case. With mocks, we duplicate behavior and structure into the test. Structure and behavior that should be in the production code are replicated in the test. And then if for a good reason I change behavior, I now have to change it in two places. If for a good reason I change structure, I now have to change it in two places.
Yeah.
So from a modeling perspective, tests always inevitably couple to the provided interface of the unit under test. There is no way around this. We have to deal with the unit under test. The unit under test has to provide an interface for that, so that coupling is inevitable. But when I mock, I also couple my tests to the required interfaces of my unit under test. I just doubled or tripled the contact surface, the structural contact surface between my production code and my test code. And that has an impact, a negative impact on refactoring.
Alright, on that note, let's conclude today's podcast. We'll continue this discussion in the next episode. This is Nikhil signing out.
This is Christian signing out.
This is Siddesh signing out.
This is Mandar signing out.